we will do that again this time. Let's see. I think it's recording now. Okay. So the agenda for today, we had some folks from Huawei who wanted to present something about a QoS controller. And also, I guess we can talk briefly about changing the meeting time. There was some interest in moving it an hour earlier. Was there anything else people wanted to talk about?
I think I wanted to do like a parliamentary procedure type thing and say, like, as part of our regular meetings, we should probably enumerate any test failures that back up the queue, just so we're good citizens.
Sure.
I don't know if I've seen any recently. I know that there were some, but if there's anything backing up the queue, whether that be reviews that are backed up or test flags.
Sure, that sounds reasonable. Any other stuff people want to talk about? I guess not. Okay, I guess we can get started. Are the Huawei folks here who wanted to? I think Rohit, I see you're on here. So, did you want to present?
Yes, David. Terry, are you there?
I'm sorry?
Yes, I'm here.
Oh, okay. Sorry, I thought you turned.
Yeah. Terry, like, you want to start or I should begin?
You can start.
Okay. Okay. Are you able to see my screen?
Yes, we can. Yeah.
That's cool. That's good.
Okay. Hi, this is Rohit here from Huawei. We have worked on some technology project on Kubernetes. I have been working on Kubernetes from the last 1 year or so. So I worked with Terry and team in the US, and we worked on this feature called resource over subscription. So I will just briefly introduce the feature. So the feature is actually about how do you manage resources between high priority jobs, which we call as latency critical jobs, and best effort jobs, which don't require any guarantee to run. We have actually taken this as an inspiration from a couple of papers that I will share in the slides going ahead. There are some existing proposals in the community that we saw, which try to address the same problem of how do you share resources between these two different types of jobs, and we still try to achieve the SLOs of the LC jobs and still try to achieve more efficiency of utilization of the resources. So we saw that there are a couple of problems in the in such community proposals. One such proposal is highlighted in the slide here. So I'll not go through the proposal, but I'll just discuss some points that we thought were not covered in this proposal. Like how do we actually measure the performance of an application, and how do you determine how to evict best effort jobs, and how do you determine which of the best effort jobs we need to drop in order to ensure the performance of critical applications. And how do you place a best effort job without knowing its resource request amount? Because currently we only care about primary jobs which can request for certain resources. For best effort jobs, we don't care about what are the resources that they request. So some drawbacks of this design are that, as I said, the best effort jobs can't specify any request or limits. So consequently, if you are given two best effort jobs, the scheduler doesn't know which one would require more resources. And since the scheduler doesn't care anything about best effort jobs, it will treat all of them as the same, irrespective of the amount of resources they actually require or consume. As I said, we took some inspiration from some papers. One of those was Heracles, which was by Christos and his team, and they actually mentioned how do you actually achieve sharing of resources like CPU or memory or network bandwidth between different types of jobs so as to improve the resource efficiency or utilization of the resources. So this was one of the inspiration for our work. Uh, on the next slide, I talk about Mesos Serenity, which is again an open source project, which actually tried to implement resource oversubscription using a QoS controller pipeline. So if you see this block diagram over here, what they have is something called as a resource monitor, which will monitor for resource usage for different types of resources like CPU or memory, and it will collect all those resources, and there will be a guy called a resource estimator, which will try to estimate the amount of resources that could be used in the future for different types of jobs. And this information is passed on to the slave, which is percolated back to the master, and then the framework in Mesos, which tries to launch a particular job, will take into account these types of statistics of which resources are reclaimable and can be used by low priority jobs, and which could be necessarily taken back or revoked back if we observe that the latency of the high priority job is going above the threshold. So it tries to calculate and it tries to consider all these factors, and then it tries to deploy both kind of jobs onto the slaves onto the same slave nodes. So this is another inspiration that we took, and we try to implement a similar mechanism in Kubernetes. So this is the high level system overview of the various interactions that happen between the components. So if you see, there is a master node and the slave node over here, and we assume that, say, there is a primary pod. When I mean a primary pod, it is a latency critical job like a database server or a web server, which has to be run continuously without any SLOs being affected. So assume that we have a pod P1, which is already running on the slave node, right? And we have a new component called as the estimator, okay, which tries to basically measure uh, the amount of resources consumed by different pods on this particular slave node. Okay, so this guy actually tries to report back the reclaimable resources, which is from pod P1. So say if pod V1 requests for 4 GB of memory, and if it is not at its peak load, it might be just consuming 2 GB of its memory. So the rest 2 GB is still reclaimable, which can be reused. So it will report these kind of reclaimable resources back to our master. And on the master node, when we get a job, actually, right? So we made some changes to the scheduler as well. I will talk about the scheduler in a later part. But what the scheduler will do is it will try to query the node status, and it will try to get the reclaimable resources that are available on this particular node. And if it finds that there are reclaimable resources, and if there is a pod P2, say, which is on regular resources, which requires regular resources, and a low priority job P3, which requires reclaimable resources. So what the scheduler will do is it will try to basically find out a particular node which is having reclaimable resources for pod P3 to run and regular resources for P2 to run. Okay. So now assume that it tries to schedule both of these pods onto the same node, assuming that we have sufficient reclaimable resources for pod P1 and regular resources for a different pod P2. Okay. So now everything is running fine. All the 3 pods are running fine. And now we observe that the pod P1's usage is going beyond the threshold. The usage could be related to memory or network IO bandwidth or any other resource. For our project, we just considered metrics like memory and network bandwidth for our technology project. But ideally, it could be any resource it could be L2 cache or L3 cache or any other shared resource. Okay. So
Hey, can
now
I
we
ask you a
observe that
question?
pod P1 is trying to use.
Can you
Yeah.
Yeah, just a quick question. Sorry, Bobby asked a question that I thought was good. When you say the low priority pod P3 can be placed on the reclaimable resources, how do you define what a low priority pod
Yeah.
is?
Yeah. In Kubernetes, if we consider, we have something called as QoS tiers, right? You have best effort kind of
Right.
pods. You have burstable pods, and you have primary pods, correct?
Yes.
Yeah. Yeah, in our project, what we tried to do was we tried to tag a particular pod as a secondary pod. If it if it says that it can accept revocable resources. So that is a part of the scheduler changes that I'll talk about later.
Oh, okay. So you
Okay.
explicitly mark the pod to say it can accept revocable resources.
Yeah.
Okay. Thank you. Thank you.
Correct. Yeah. So yeah, continuing ahead, like now we assume now we find out that the pod P1's usage goes beyond its threshold. So now we need to take some action. Okay. So what could be the actions? The actions could be we could free up some memory by explicitly killing a particular best effort job, or if we want to take back the network bandwidth, what we could do, we could just pause a particular best effort pod, because that would stop doing any network IO. So these are the two possible actions that we consider in our framework. We kill a pod, or we freeze a pod, or we unfreeze a pod back to its normal state if we find that all things are normal with respect to network bandwidth for a pod P1.
Real quick question.
So this is the overall yeah.
Don't you have sampling problem here in order for you to detect that pod P1 exceeds a threshold? Because sometimes it could be bursty, right? So if pod P1 is suddenly bursts,
Yeah, correct.
Yeah.
Hmm.
So right now you're banking on your QoS
our,
controller banks on the fact that there's some latency to detect it, right?
Correct. Yeah, so our algorithm actually is quite primitive in the fact that we try to actually maintain the last 10 samples from C advisor for a particular kind of a metric, like say memory or network bandwidth, and we try to predict in the next interval that we are trying to monitor what could be the rate of increase in a particular kind of a resource. So we have a very primitive formula that will try to calculate this, but of course we could try to improve upon how do you predict whether uh, whether this pod's resource usage could burst in the future. Did I answer your question?
Yeah. So there's two problems with their sampling sizes. You're doing a windowed across the C advisor samples, but the C advisor samples have their own window too. So you could have a burst in between those windows, and you'd have no idea. So I'm just trying to like point out sort of the catch-22 issues that you're having here. But I see what you're trying to do.
Yeah. Okay. Yeah, I think yes, we also know that like our algorithm to predict is very naive, and we could improve upon it. So we would like more inputs from you guys.
Tim, I think
okay. So if you
I was just saying a counterpoint about the revocable, or I forget what you called them, the reclaimable resources. I think that the sampling lag is not as much of an issue because there's no guarantee associated with that resource.
But pod 1 was the guaranteed resource, and pod 3 was the fuzzy one. So if pod 1 reaches the value, it was guaranteed originally.
Yeah, but it still gets that guarantee, but pod 3 gets punished, right?
The problem was that pod 1 was approaching a threshold. We gave some of pod 1 away, right? So we could run pod 3, but there was no, once pod 1 actually needed its original request or some value higher, or some value that was within its original margin, right? And we needed to interrupt pod 3 and go back and give that space back to pod 1. but that sampling interval was the problem. So we're basically punishing the person who had guaranteed.
Yeah. Yeah, okay. I guess you could just give it minimal. I mean, if CPU is the issue, you could just give it minimal shares and then let CFS throttle it down. But I don't want to derail.
Yeah, CPU is not the question. I think it's non-compressible things, right?
Yeah.
I mean, maybe.
So, yeah, we have,
Yes, and we don't handle the CPU as well.
Yeah, we have a somewhat similar question here. I guess for certain priorities, for example, for a job which is latency critical, you should never take resources away. Even if your resource estimator believes that it uses like half of the resources that it has asked for, you should never take resources away from certain types of workloads. We don't have the concept of priority yet in Kubernetes, but we are trying to add it. So probably depending on the priority of the pod, sometimes you may or may not want to take resources away. So for example, if the priority is really high, you may not want to take resources
Sorry,
away.
I'm not everybody seems to agree that you wouldn't want to take resources away from high priority pod, but I'm not understanding why. Can't you just kill or throttle the opportunistic or low priority one when you get into a situation where the high priority one suddenly needs the resources?
You can, but the problem is that if your workload is latency critical, you may not be able to do it quickly. So if, for example, my job suddenly wants to burst on CPU or memory for, I don't know, a fraction of a second or a millisecond, you may not be able to kill other jobs quickly and give resources back to the one.
Yeah. Imagine a world where you run Java. And then all of a sudden you need more memory because it's Java, right?
Right, but I mean, so if you need more memory, won't the system, in the worst case, I mean, we have a user space out of resource killer, but even if that didn't exist, like wouldn't the system killer kill based on like the scores, and you could set the scores such that the high priority pods would not be killed or would be killed last?
You could, but depends on how much latency you can tolerate. So if your tolerance for latency is like a millisecond, then probably it's going to become too late if you want to kill the process. And
I see. So you don't want to wait for the reclaiming process to happen, basically.
So if you look at the Heracles paper, what they did was they tried to maintain headroom across a number of hardware resource vectors, including things as low level as like voltage across the chip and stuff like that. It was based heavily on specific tuning data from the low latency application they were protecting.
Yeah,
I see.
Not easy, but you definitely need something faster than the kubelet sync loop. So you need to be able to act on the node.
I see. And so then the way you do that is with you reserve extra headroom for the high priority things or the latency sensitive.
we do the same thing in board.
Yeah. I was just okay. I see. Thanks for the explanation.
All right, you can continue your presentation. Sorry for interrupting.
No problem. Thank you. So I think we covered like most of the things. So I'll just rush through the slides. So yeah, so this is just a overview of the resource estimator function. It collects the metrics from CAdvisor, and there is a data smoothing and forecasting mechanism, and then it tries to update the node status with the reclaimable resources. The QoS monitor will try to monitor the applications, and it will try to perform corrective actions. So we have a monitoring interval which is user configurable. Yeah.
Hey, so I saw that in the previous the diagram, you do have when you say forecast the resources, so you are taking into account the threshold. Remember the headroom which somebody just mentioned as part of the smoothing and the forecasting thing. I'm assuming you're going to take care of that the threshold for that the latency critical job as well, though, isn't it? Because yes, because let's say you're
Yes, yes.
yeah.
Hmm.
So you factor that in as part of the the data smoothing and the forecasting step. So I'm assuming you're gonna factor in the headroom for that latency critical job as well. This is
Yeah,
how the
we
Hercules
haven't
paper does
actually
that as well.
like specifically focused on the headroom stuff, but yeah, correct.
Oh, okay, okay.
I have a question. Uh, it seems to me the way
Yeah.
we are addressing a problem here, like uh, we need to reclaim resources. My question is, like if there is a
Hmm.
pod like P1 and its minimum requirement is 2 GB,
Hmm.
then why not start with 2 GB?
Hmm.
And I mean, I'm trying to say like how it might be better to pose this problem differently, and as its requirement increases, then if there are other pods that are not of high priority, then instead of reclaim
Hmm.
resources, we should give it more resources, and because it's a high priority, we should maybe kill other lower priority.
But
Lower
the thing is, the user specifically mentioned that I want to reserve 4 CPUs. So the user doesn't know that, you see. So as you find out by constantly monitoring that application, that even though he reserved 4 CPUs, but in last 10 samples or 50 samples or whatever, the exponential smoothing or whatever, you find out that he's using only two CPUs. So we're gonna take 2 CPUs away from him, you see. So the problem is the resource estimation versus the reservation issue, you see. Or you either upfront, that even though user is asking for 4 CPUs, but actually, based on this application type, he may only need 2. So that's called a resource estimation thing. So yeah, so that's another approach, but that's not something we are doing though.
Yeah, my question is like instead of approaching, instead of initially assigning the upper bound or whatever bound is that, why we don't approach it that we start with something and then we increase or decrease depending upon the requirement of the high priority pods, and then we take actions on the other pods, lower priority pods.
Sorry, you start what? What was the thing that you start at that value? Like, I mean, I understand correctly.
Yeah.
You're suggesting to start from some lower value, not from,
Lower bound. Yeah.
Yeah,
not from the request. But how do you pick that value? Like, it seems like
Yeah.
dangerous if you are not conservative enough in picking.
Yeah. Well, I mean, you could channel Quasar and have history, right? Because we have no infrastore. So, like, if we had an infrastore, we could have something that would affect it on ambition, right?
Sure. Yes.
Yeah, the resource estimation thing, the Quasar paper, those guys have done. So you can, instead of doing a resource reservation, you can estimate the resources and you do the allocation and assignment. That's another approach, but that's something different though. I think what he's suggesting, but how would you know the lower bound? How would you know if the user said 4 CPUs? How would you know that you need to start out with 2 CPUs?
okay, so it's like we only are aware of upper bound, because the way we have in Kubernetes, we always have like request and limits. So request is like a lower bound, we make available for pods. So that's how like I was suggesting, like the concept, we already have concept of request, and so we start from there. But yeah, I mean, I get your point of.
Yeah, correct.
Yeah, thanks.
Yeah, so in our implementation, we have actually accounted for the requested resource itself, and not the and not the limit, because in case of the limits, right? If you have this OM killer or the eviction manager, right? It would anyways take care of killing pods if they go beyond their limits, right? So we just consider the requested resources, and we have some thresholds around those. and not the limits.
Yeah, maybe the only thing like what I'm trying to say, like if we start from the, I mean, I understand you are saying the user does not know about the minimum, but like I said, like anyway, you have something called like request, and we are starting from there. So my point is, instead of reclaiming resources, I mean, we don't have to go, we don't have to care about reclaiming resources. Uh, uh, we just keep scheduling more pods, maybe lower priority pods, until the higher priority pod asks for more resource. So I don't know if it makes sense or not, but anyway, yeah, you can go ahead. Thank you.
Okay. Yeah, so the corrective actions include killing a pod by doing a Docker stop. So the Docker engine provides the way to kill a container, or yeah, if we observe the network bandwidth is going beyond the threshold for a primary pod, we try to freeze a particular secondary pod by doing a Docker pause. And if we find that the LC job that has not like is now well within control for its network bandwidth, we try to do a Docker unpause and try to unfreeze a particular frozen container so that it can resume its normal operation.
So what does
So
Docker?
this is the process diagram for the QoS controller.
Like if you do Docker pause or Docker unpause, like how does that show up in the Kubernetes API?
Mm-hmm.
Like if you do get pod, what or describe pod, what state?
It will, yeah, it will.
Are you still there, Rohit? We can't hear you anymore. I think we may have lost him.
Yeah.
My guess is running still.
Yeah,
Well,
I mean, I don't think this is something that's supported natively in Kubernetes. So I was just curious, like how it shows up to the user when you do a pause or unpause. I mean, it's a minor detail. I was just curious.
I think it would use the freezer C group control.
What?
I think it would use the C group freezer controller.
I don't know what.
I've not heard of that before. What is that?
Because that isn't totally bug ridden, but
yeah, but it just takes those tasks out of rotation for scheduling.
I see. So the kernel won't schedule the processes anymore, but Kubernetes will still show it as having like as running, as like Tim was saying, or something like that.
Probably, yeah. Unless the kubelet is looking for those.
It will still continue to yeah. I think it will still continue to hold the memory and CPU, but it will it will stop doing any network I/O if it was doing.
Wait, it continues using CPU? If it's paused, that seems unlikely.
Yeah, and memory. Even the memory.
This applies basically pause on pause applies only to the network interface.
The C groups won't relinquish their space, right? If you're using the freezer, which is a crap factory, if you're using the freezer, it's only going to prevent you from executing, but it's still going to reserve the space. So the reservation's still there.
The memory is still there, yeah.
And the CPU, like the CPU
correct.
quota or the CPU shares are still allocated to that.
Well, I guess if it's not being considered for running, then those shares don't count.
Right. They're used, right, but it's still kind of those shares still kind of belong to that.
Everyone else's shares would get inflated linearly.
Yeah.
Right.
But another approach could be do a checkpoint restore as well. So you can checkpoint the container and then restore it when you need it back.
For sure, yeah. That would be better, probably.
Yeah, because then you don't have memory in there in the system anymore. So when checkpoint is gone, then you restore it.
Mm-hmm.
But yeah, the whole restore time, there's a lot of research. There was a paper came out, the
Yeah.
Pico Center guys, they did the active memory thing actually. So they don't bring back the whole memory. So the restore process is pretty fast. So there's a lot of work going on there as well. But this is kind of a starting point. You can do freeze, unfreeze, and then potentially you can do checkpoint restart as well.
Yeah, I'm not sure about checkpoint restart. You have to consider a lot of
Okay.
other things because we are talking about maybe a whole system, pretty much, not a single process, right? When we're talking about containers, it's not going to be.
Oh, the part you mean to say? Yeah, you're right. And the checkpoint restart is at the container level, but you're right. It needs to be abstracted out at the pod level, the checkpointing and restoring. Yeah, you're right. Yeah.
Yeah, it has to be at the pod level, and it's not going to be that easy. I mean, sometimes when the time passes and the state of the whole cluster changes, it may not make a lot of sense to restore a pod. Well, this is
Yeah,
not a.
I don't know. This is hypothetical.
Very
hypothetical.
Yeah, this is a much longer conversation. We should not go into.
Yeah.
Let's go back to the presentation. I'm worried we're going to run out of time because it says like on slide 14 of like 35 or something. So.
Okay. Yes, I'll just run through the rest of the slides. So this is the overall framework. So what we have is we have an initialization from a JSON file, basically a config file, which will have some thresholds for different types of resources. And there is also a flag where you can enable or disable this particular feature. We could also pass it as a flag to the kubelet when it starts up. But for simplicity, we have kept it in the JSON file. And the first step is we acquire metrics from CAdvisor. And then we actually try to run through a series of controllers, and each controller just focuses on one type of resource. So if you have a memory controller, it will try to find out if there are any existing secondary pods which can be killed if the LC jobs memory is above the threshold. And it will simply build a list of actions of which pod to kill, or in case of a networking controller, network area controller, it will tell which pod to freeze or unfreeze. And we haven't built this particular shared resource controller which accounts for CPU cache. And there is another controller which we built for SLA based mechanisms, where we try to measure the application performance latency of LC jobs, and then try to take corrective actions.
Just
finally, there is an executor which will run through the list of actions. Yeah.
There's a big lag from me asking a question to like the audio. So just out of curiosity, is there a have you thought about just taking CAdvisor out of the mix? Because there's a ton of low latency utilities for monitoring to do smarter, because you're almost running these as daemon sets, right?
Mm-hmm.
So if you're running it as daemon sets, you could take CAdvisor completely out of the mix.
Yeah, correct.
And use a whole host of other monitoring solutions that are much faster and give you much more detailed information.
Yeah, okay. Actually, I'm not aware of those solutions. So yeah, it would be of great help if you could point me to those, so that we could consider those as well.
So I had a quick question. I didn't see like CPU. I saw CPU cache and bandwidth, but not CPU. Is there a reason? And also, you mentioned networking. I don't think there's a way to reserve, like we don't have network bandwidth as a first-class resource in Kubernetes. So where were you getting like the network request for doing it with networking?
Yes, so the network bandwidth we actually query from CAdvisor. CAdvisor provides you an API where you can get the transmitted and the received bytes, TXRX bytes.
Right, but like,
so we use those metrics and try to calculate. Yeah.
So you calculate like a reservation or whatever, but like, how do you reclaim resources? Because you can't request network bandwidth currently, at least not using the standard V1 fields.
Yeah, correct. Yeah, so explicitly, a user doesn't request for any network bandwidth, but what we observe is over the last, again, n samples, what is the network IO usage for a particular pod, and based on that we try to do some actions. So it is like internal and not exposed to the end user, but he can say that he would like to reuse some available network bandwidth if possible. So it's all data from C advisor that we rely upon again.
And what about CPU? I didn't see CPU on this list. Like I mean, it says CPU cache, but not CPU. Is the CPU part of that?
Yeah. No. So we did not implement this part, but we intend to also implement this particular controller since we saw this in the Heracles paper.
Yeah, but what about like
but
CPU?
it requires some specialized hardware. So
Rohit,
yeah,
the question was, how come we don't have a CPU controller in there?
yeah. I think the CPU we explicitly don't try to control, right? It should be taken care by, as we discussed in some discussion in this meeting, right? It should be taken care uh, uh, by Kubernetes itself. Like if that particular pod is not using that particular CPU, it should be anyways be usable by other pods or something, right?
Okay, well, we should probably move on. Just like I think
Hello?
maybe 10 more minutes or so.
Yeah. Okay. Fine. Yeah, typical process of a controller would be again like take the action list from the previous controller and then try to check the thresholds for the particular type of resource, and then if it exceeds the threshold, we would we would sort basically by descending order of usage for a secondary pod, because there could be multiple secondary pods that could be there on a node. So we would take the top pod from that, and we would try to kill or freeze it. And if it is not exceeding threshold, we would try to unfreeze some frozen pods so that they could start functioning normally. So yeah, so I would just skip the scheduler changes, but just to note, we took this from the Tarsil paper where it tries to actually schedule short jobs. Short jobs are jobs which could actually execute in a very quick amount of time or a short span of time, and we could actually use some revocable resources to execute this kind of jobs. So I would not go into the details of the flowchart as we are over time. So just an example, we would like have this kind of a pod which would request for revocable resources, and if we are able to successfully schedule that, we will annotate it as like this is secondary is true in its annotations. So in our controllers, we will check whether a pod is a secondary pod or not, and then take corrective actions.
Are you guys running at really high utilization?
Yeah, so I think I'm done.
Yeah, my only question I had is like, what's your average utilization that you guys are running at?
We actually try to measure this, measure the performance, and we saw around like 20% improvement in the resource utilization as compared to without using the QoS controller. So yeah, so that was the result of our tests. We try to benchmark and try to run some. Sorry.
No, I was just curious what workload you use, but you said you use some like synthetic benchmark. Is that right?
Yeah, we use some open source tool called program stress or something, which allows you to apply stress on different types of resources. So it is an open source, I think, Docker image that is available. So we just try to use that and try to simulate some workloads.
And when you say, so the workloads were like randomly generated or like based on a model of actual workloads, or how did that work?
We also use the workload from the Google cluster data.
They were just random workloads.
Oh, I see.
Mm-hmm.
Okay, thanks.
Teddy, you want to add anything onto it? Teddy?
No, I think it's good.
Okay. Yeah, thank you everyone for your time, and that's it.
Okay, thanks. Sorry, I thought that I saw at one point the number of slides was much larger than what you showed, so sorry about rushing you. I guess we have a little bit of time if people wanted to ask questions. We could just save 10 minutes at the end for the other topic, but if people had any questions about it, I think we have time for that.
I did have a question with your average utilization of your cluster and the average utilization of your nodes. Did you measure that beforehand? Because you gave a number at the end, but I was just kind of curious of the before and after.
Teddy, would you like to answer that? Maybe you could take it up.
Well, this is how we do the experiment. I don't have the exact number with me right now, but we do the experiment in this way. So we use the Google cluster data and use that data to create some synthetic workload. So from different type of workload, and then we start all those workload and measure for some latency critical applications. We measure the latency, and then we enable the resource reclamation, and so it allows us to deploy more workload onto the existing cluster, and then we measure that extra. We see how much percentage of the workload can we deploy onto the cluster, and that's basically we got that from. We try to deploy more workload into a cluster without sacrifice the latency from the critical jobs.
Okay. Are there other questions? I mean, I had one question, which was like, are you going to make the code for this project available, like in a GitHub repo or something like that?
Yeah, I mean, that's what we wanted to kind of find out. I think Rohit mentioned that as well. This is Deepak, actually, that there's already some PR that which we think there's some issues with that. So we wanted to kind of find out, where the synergy is. Is that something we should kickstart the process, or is there something we should collaborate with the existing effort? I mean, that's what we need to find out, actually.
Yeah.
That was the whole thing. We wanted to demonstrate. Essentially, what we have done is we implemented the Heracles paper. So, and obviously we didn't implement all the way, but some of the pieces are missing. So, is that something could be a starting point, or is there something we should work with the existing issue 2.3, 2.8, 3.5?
So I don't think anybody had started working on this yet. I mean, Balaji filed that issue from Intel. Maybe Connor can speak to this, but my understanding is nobody has started working on this yet. Is that right, Connor?
That's it's pretty accurate. What we did do was we created a project to try to identify the problems of co-location on top of Kubernetes. I can drop a link to that project into the Slack. It probably applies pretty well. In terms of having some sort of like a externally provided isolation policy, that is an ongoing discussion. I think it's, that topic came up in the resource management work group face-to-face last week. And currently it's not on the agenda for anybody to work on. But what is on the agenda is, trying to differentiate what the different QoS classes mean and providing some more incentive to, to be a guaranteed pod. And so there's going to be some work coming out of that around CPU management, at least. So, this kind of work I think is applicable to the general direction, but probably like 1 or 2 steps further than where people are planning to go in the next couple of releases, at least.
I mean, the thing is, from our perspective, the code, we already have a code, the basic code of the implementation of Heracles. So we don't mind. I mean, we would love to do that. Like we can, start a PR or whatever, and then maybe start the process, and other people can start contributing towards that. And I mean, if it makes sense.
I wonder if Connor, and Tim, would it make sense to do like a Kubernetes incubator repo for it, or do you think this is not mature enough yet for that, and it should just stay in a separate repo, or what do you think?
Incubators are based upon if there's enough resources and sponsors and whatnot. I think it makes sense to have it as an incubator for people to chime onto if people are interested in, if Intel is going to commit resources to it, or if other people besides Huawei, I guess is the answer.
Well, so we are definitely, we're going to commit resources for sure. So that from Huawei side, yeah.
So, yeah, so Balaji, who's one of my teammates, submitted that issue. You can see it was over almost a year ago. And I could say, from having worked on similar things in Mesos before and, related things internally at Intel, the issue isn't, isn't the technical difficulty of writing the code. It's convincing people that it's the right thing to do. So I think, maybe having this same discussion with SIG would help to alert more people who may have a stronger opinion on this sort of thing.
Well, I think the one benefit of the way they did this is because they're daemon sets. There's nothing on the node side. It's all scheduler side and daemon sets. Is that correct? You didn't hijack the kubelet.
Well, Rohit, I think we did. So how do you get the pod statistics?
We are just running. Yeah.
Go ahead.
Well, the daemon set can collect the statistics from CAdvisor. But yeah, I'm not sure what Tim said.
Well, how would the daemon set know the pod? Because anything coming out of CAdvisor has a container level information. You see, so you have to kind of talk to the kubelet to get the pod. To be able to aggregate that information for a pod.
That's true. I don't know.
Yeah.
And actually, along the same lines in what Connor already said, I guess it makes more sense, or at least I would more comfortably use it after there is a more sort of like robust way of defining priority for pods. Without priority, it'll be always a little bit.
Sure. Well, I mean, they had these they weren't anything. The new fields they introduced in like the secondary. There's like a Boolean secondary, and then they had the users reclaimable resources. So I don't think we would use the exact API you had, but the concepts probably are reasonable. And yeah, I think I agree with Bobby. Like, maybe we would infer those two properties from the priority and the quas or something like that. I don't know. I mean, this will require further discussion.
Yeah, I mean, those are the things. Obviously, that's the reason. I mean, so we wanted to reach out to the community. So, what's the best way of exposing that? Those kind of properties, essentially. See.
Right. So. Yeah, I mean, I don't think we can design it in a meeting, but I think the right question is like, should this be an incubator project, or what should we do with the code? Connor, I didn't get it wasn't completely clear to me what you were recommending, or Tim. I guess, Tim, you were saying that you thought an incubator was probably reasonable. As long as someone outside of Huawei had interest in it.
My two constraints were someone outside of Huawei has interest in it, and you don't go deep into the kubelet to refactor, because that's a political issue.
Yeah, so did you guys, I guess we didn't get a completely clear answer on, did you make any changes to the kubelet?
Yes.
Yeah.
Yes, we did make some change in the kubelet.
What can you very, very, very briefly say what you did?
Well, like that cycle. So that
So,
cycle.
so in the kubelet, we just yeah.
I don't hear you. Go
Yeah,
ahead.
carry on, Terry.
Terry, go ahead. I think you said you could go ahead.
In the kubelet, we just we have a go routine. In the kubelet, we start a go routine basically, which will run every monitoring interval, and all the code has been decoupled and written in a separate QoS controller file.
Oh, that's the sampling. I
But
think
yes,
that
it will run
answers
as a
your
part of
question.
the
I think
kubelet.
that David, your question was what exactly are we doing in kubelet? I think that the sampling thing, the 10 samples which we, Rohit talked about, I think that's the code we do that at the kubelet level, isn't it, Terry and Rohit? The last 10 samples.
Yes, correct.
Why can't
Yeah.
those are from C Advisor though? Why couldn't you just collect those from outside of kubelet?
Oh, like Heapster? Like Heapster?
No. I mean, you could have the daemon set that's running on the node.
Yeah.
Could aggregate those 10 samples. Anyway, maybe we shouldn't design this here. Connor, do you think it's reasonable to was okay with doing an incubator for this? Do you think that's reasonable, or do you were saying maybe it should wait until there's more discussion with the SIG node or with the understand how it fits into the other work that's going on?
Well,
but if they have code already, maybe it's okay.
I don't want to stand in the way of anyone, doing work. So, I wouldn't block it. I don't have the authority to do so anyway. But yeah, I just think that some folks in SIG node probably have an opinion. They want to know the details of exactly what's going on with your interaction with the kubelet. In particular, they're probably sensitive to anything you're doing, like going behind the kublet's back to kill containers, or muck with the containers that get set up behind the CRI interface or anything like that.
Yeah, I think the Docker pause thing they probably would not be happy about. But I mean, the rest of the stuff might be reasonable. It didn't sound like there was much change to kubelet, but yeah. So maybe they should present this at the SIG node meeting, or
this also has some sort of preemption as well. So that should be discussed.
All right, well, maybe we should discuss that more on the mailing list. But I think that the general feeling is that there's a lot of interest in this, and at least as an experimental thing to play with. And so we would like to get it somehow into a form people could more visible than just being in your private repo or something, probably.
Yeah, so we can do that. So we can start off a thread and then, just send out the PowerPoint and just kind of explain more. I think the kubelet thing, we can explain what exactly we did, the details, that some of the things are not really clear. What exactly we did, changes at the kubelet level.
That would be great.
So, yeah. So we can do that, start the process, and then we can potentially, so incubation could be a potential starting point.
I think that sounds like what folks are saying here. Sounds like Tim is on board with that. Sounds really
okay, great.
Yeah, thanks all of you guys for presenting the work. It's definitely very interesting stuff.
Yeah.
A lot of in real world systems like Borg has a variant of this, and so it's definitely something that's useful in the real world. So yeah, that's great. Thanks.
Okay, thank you.
3 minutes left. I wanted to quickly. So there was a proposal to move the meeting time.
Thank you. Thanks a lot.
Does anybody have an opinion or object to that? I mean, the advantages are that folks on the East Coast, it's a little more convenient because then the meeting would end at 5 p.m. instead of ending at 6 p.m. And also, it would be a little more, nobody from Europe seems to ever come to these meetings, but it would be more feasible for them because then it would end at 10 p.m. instead of 11 p.m. And so maybe somebody from Europe would come, although nobody has ever really expressed interest. Malte came a couple times, but then not after that. So I don't know. And actually he wasn't, no, it was Jan, not, anyway, one of them. Never mind. So anybody have an opinion one way or the other on moving the meeting 1 hour earlier?
Should be fine. And
Okay. All right.
well,
yeah, go
so
ahead.
David, just to let you know, we are very closely working with Unal and Malti on that fermenting integration with us. So down the road, I think in the next month or so, we will present that as well.
Yeah, that would be great. I know
yeah.
Quentin mentioned that in his
Yes. So I'm actually working very closely with Unal. So I mean, at this point, we're not ready. Within a month, we should be ready to kind of present it, and can I get your perspective and all those kind of things.
Sure, that would be great. Thanks. So it doesn't sound like anybody objects to moving the meeting an hour earlier. So I think we should provisionally say we will do that. I'll check again on the mailing list to make sure nobody objects, and then we can confirm it for the next week. And we will be recording the meetings religiously. We did last time, and it seemed to work, and I'm doing it this time. So folks who can't attend can watch the video. And I'll upload those to YouTube on the following whatever the procedure was that we're supposed to be using. Tim, we have 2 minutes left. Do you want to say something about the test failures that you mentioned at the beginning of the call?
No, just that I think, as like a point of parliamentary procedure, like we should probably outline them every time we have a meeting, so that way someone can go fix them in case they weren't paying attention to it. Because last time we knew that there were issues and they just kind of hang around for a long time.
Okay, should we have someone who's officially responsible for like bringing the list of test problems to each meeting?
That would probably be a good idea.
Are you volunteering to do that, Tim?
Are you volunteering me? I suppose I can, actually, because I go to the SIG testing meeting, so I can get that list.
Great. That sounds great. I think it's a good idea, and it's even better since you're volunteering to do it.
Since you volunteered me to do it.
Okay, cool. Thanks. Anything else? We have like 1 more minute. Anything else people want to talk about? Sounds like not. Okay. Well, thanks everyone. And I guess we'll see you next time.
Thanks everybody.
Okay. Yeah. Thanks again for the great presentation.
Bye-bye.
Bye.